Well, hello there, Mr. Sutton here. I have the IM3 Honors 1-1 Part 3 homework solutions on domain, range, and functions. For C now, we're doing f of x squared minus 1. Yes, you can replace x with another expression that has x in it. It's kind of weird and seems like it should be illegal, but it happens all the time. So this is going to be 3 parentheses x squared minus 1, all of that plus 2. This one we can simplify a little bit. So this will be 3x squared minus 3 plus 2. So 3x squared minus 1 when the dust settles. We've got 3b plus 4 being plugged in here. So this whole 3b plus 4 parentheses is going to get squared. And then we have to expand that out. So if we square the first thing, that'll be 9b squared. Multiply these and double it. Let's see, that's 12b times 2 is 24b. And then square the last thing, we've got 16. For 13, we have the function x squared minus 5. And we're starting off with f of negative 5 minus f of 2. So I'm going to do these two things completely separately in kind of their own brackets, and then I'll put it all together. So we've got negative 5 squared minus 5 in one bracket, and 2 squared minus 5 in another. So this first bracket, this is f of negative 5. This second one, this is f of 2. So over here, this will be 25 minus 5, and here we'll have 4 minus 5. This is then going to be 20 minus negative 1, which is 20 plus 1, or 21. For part B, I've got f of x plus 1. So that means I'm going to have x plus 1 squared minus 5. So instead of x, I'm writing x plus 1 in parentheses there. I now have to expand this. So that will be x squared plus 2x plus 1, all that minus 5. And then this will be x squared plus 2x minus 4. And then we get to part C, kind of the final boss battle of this problem. We've got f of x plus 2 minus f of x plus 1. Ugh. Well, we're going to have two brackets, one for each expansion. So we've got x squared, or rather x plus 2 quantities squared minus 5 in one parentheses, one bracket. And then we'll do x plus 1 squared minus 5 in the other. So doing our expansion, this is going to be x squared plus 4x plus 4 minus 5. And here we've got x squared plus 2x plus 1 minus 5. So if you haven't gotten really good at these squared parentheses, now's a good time to start because you're going to keep using it. Simplifying over here, this is x squared plus 4 minus 1. And over here we've got x squared plus 2x minus 4. And then if I distribute that negative, I'll have negative x squared minus 2x. And it was initially minus 4 in here. If I distribute this negative, that now becomes plus 4. And over here, I'll just drop that bracket because there's nothing out in front of it. Combining like terms, the x squareds are going to cancel each other out. We've got 4x minus 2x, which is 2x. And negative 1 plus 4 is 3. So 2x plus 3 is what all of this simplifies to. On this problem, I'm given the function f of x equals 2x minus 4, and I'm trying to find f of 3 plus f of p plus 6. So there's a lot going on in this one. I'm actually plugging two different values into the same function, and then I have to kind of pick up the pieces after I do that. So f of 3 means we're going to replace the x in the original function with a 3. So we're going to have 2 times 3 minus 4 for that piece of it. And I'm going to put that in a bracket just to kind of keep that separate from this other stuff. Now for f of p plus 6, now I'm going to be replacing x with p plus 6. So I'll write 2 parentheses p plus 6, because I'm still multiplying, minus 4. I'm going to put all of that stuff in a bracket, which I'm going to be adding to that first bracket. So this first bit of stuff was f of 3. This second bit of stuff was f of p plus 6. Now I just keep simplifying until I can't anymore. So we've got 2 times 3, which is 6, and then we'll be subtracting 4 from that. So that would be 2 ultimately, but we'll leave it as 6 minus 4 for now. This next one, I can distribute this 2 to the p plus 6. So that's 2p plus 12. Still have that minus 4 in there. And again, we're still adding these together. because we were adding the f of 3 and the f of p plus 6 in the beginning. Going a little further now, we've got 2, 6 minus 4 is 2, plus, this is going to be 2p plus 8. And then finally, we can combine the 2 and the 8 to get 2p plus 10. For this problem, I've got 2x minus 4 as my f function, and I want to do f of all this stuff, m plus 5 quantity squared. So basically, wherever I see an x in the original function, I'm going to swap that out for an m plus 5 squared. So I'm going to be doing 2 times this stuff minus 4. Now, I do have to simplify this a bit. I'll start by applying this exponent. So I'll have 2, and then I'll open a parentheses. First thing squared is m squared. Multiplying these things together and doubling it gives me plus 10m. And then finally, 5 squared is 25 in there. Still have that negative 4 outside as well. Now I'm going to distribute this 2 to everything. So we'll have 2m squared plus 20m, 2 times 10m. And then 2 times 25 is 50. And again, we still have that minus 4 there. Last step is just to do 50 minus 4, which is 46. So 2m squared plus 20m plus 46, final answer. On this one, we're doing f of x minus 3 squared for 2x minus 4. So wherever I see the x in this original function, I need to replace it with the stuff inside the f bracket here, the x minus 3 squared. So I've initially got 2 times something minus 4 is what's basically going on here. So I'll do 2 times x minus 3 squared minus 4. Now I am going to have to go ahead and simplify this, and just to make it clear, this x and the x in the original function are not necessarily the same x. Totally different x's here. So anyway, let's expand this parentheses first. So that'll be a 2 parentheses, and then we'll have an x squared. And now multiplying these together and doubling it, that's minus 6x, 2 times negative 3x. Negative 3 squared is going to give me positive 9. And I still have the negative 4 out there from before. Let me distribute this 2 now. So that's 2x squared minus 12x for the 2 times 6x. And then 2 times 9 gives me 18. Still that negative 4 out there. Now we just have to do 18 minus 4, giving me 14, along with the 2x squared and the negative 12x for my final answer.